Hello, welcome to my peer credit assignment for managing machine learning projects. My name is Ahsan Raza, and for today's agenda, what we have is for the opportunity which I will discuss with you. First of all, we will evaluate it, then we'll do the crisp DM business understanding on it, and also we would validate our solution plan, and I would just explain a bit of the solution design and the system design, the ML system design which I propose, and we'll also discuss the risks in production which we can anticipate right now. So to start with, so the opportunity which I'm proposing right now is all the financial institutes like banks, they have this legal responsibility. First of all, of course, they have moral responsibility too, but mainly it's a legal responsibility that they should restrict the money laundering activities being utilized by their banks. And money laundering, it costs a lot to the society, and also there's a lot of tax saving happens to that, so there's very less money left for the to be spent on services in the countries where this money laundering is happening. But it's not humanly possible to detect all those transactions, as there's more and more financial transactions happening all around. So this is a really good opportunity which we can use through ML. So first of all, we'll see, is there a problem? Yes, of course. It's not humanly possible, like average people of 50 60 transactions at least a day they would do through their cards and stuff. So there's loads of transactions happening by the people. If humans would start trying to find out how many of these transactions have the criminal intent, it won't be yeah, that possible. And can machine learning help to solve this problem? Yes, of course. It's quite feasible to use ML because we can use historical data to train our models, and also these live transactions which will be coming, they will be keep coming to the model, and model can be further refined. So ML is a good solution for this kind of problem. And does someone care? Uh, as I mentioned before, it's these criminal payments, they have cost to society. They've been used to pay bribes, and also loads of criminal payments like money, drugs and stuff is money laundering is used for that. So societal harm, of course, and also if we fail to restrict these services as in financial institutes, there's a compliance issue and hefty fines, and the cost of reputation, which eventually affects the revenues. So yes, like yeah, people care about that. So next thing which we'll do the crisp DM business understanding on that. So first of all, we'll check the problem. So our target user are financial institutes, compliance teams. So compliance teams would be assisted by this ML model, so they don't have to manually see every single transaction. Of course, it would help them reduce the cost of hiring and training people to do that. But more importantly, the main thing is that like the volume of transaction is so high that the chance of error is so much. And so these compliance issues, why it matters, because the banks can become more compliant, and these regulators won't find them, and more importantly, like they would come into that level that these regulators would give them the stamp, like these institutes are using best practices to make themselves compliant in doing these activities. So of course, if we restrict the societal harms, which because of the less criminal activity we've been used by using these payments, so it matters in that matter. So how it is solved today? So compliance teams use sample data based on the high risk locations sometimes. So they do profiling, laws of profiling. They use intuition also, like as a human intuition is quite common. or past experiences to find anomalies in the transactions. So success rate in detection of these criminal activities, that's the reason it's very low, because it's based on a lot of heuristics and past experiences, which and the fraudster, they are getting innovative day by day. So it's always chase game to find these activities. So there are gaps in the current stat. Of course, large data is not easy for humans to go through. We are not designed for that. And sampling means that there are many transactions which are not even considered to be checked. And ML can help in that concern. And there's a loads of profiling of these samples happen, which is potentially biased, and success rate, that's the reason it goes low. Of course, ML would make this process more tedious, quick, and large data can be analyzed, and also it would be in a continuously learning mode. These models, so it's not like they would these models, they would train themselves as more and more data would come. So we have to work on some metrics so that we can define what would success looks like. So uh, the main model which we can use is increase in success rate of detecting anomalies. So it will make institute more compliant. So if we are detecting more anomalies, we are more compliant we are. And improvement in customer trust, and that's resulting in the higher retention of the customer, and of course subsequent revenue from those customers would be coming, and the word of mouth would end up attract more customers also. So institute reputation always helps attracting more customer and better branding, which will result in a higher revenue too. So we would have some constraints. One constraint which we would have is the time. So if it would be helpful, of course, if transactions are detected quicker. So that constraint we have. The metrics which we can use are two types. One would be the outcome metrics. Second would be output metrics. So for outcome metrics, we'll see that there's a rate of so if we were detecting if we are detecting more anomalies, at least 25% increase in detection of anomaly, it means like our using going on ML route is cost effective and also effective too in other way too. And output metrics is improvement in MSC. So if it's lower than 3%, we can see our matrix is our model is successful in detecting those anomalies. So there are some factors which can affect, like geography, like certain less regulated places have more propensity of emanating fraudulent transactions. Is quite common. So other factor which can affect seasonality, like in certain seasons, let's say Christmas time, when online sale goes up, so the transaction also shoot up, so it can raise some false red alerts to the models too. So we need to be careful about that. Second thing is economics. In challenging economic times, there's more tendency towards finding risky ways to increase earnings. Hence financial fraud goes up also. So these things need to be considered. So we would validate our solution in 5 iterations. First of all, in first iteration, we'll find the sample data set for our potential solution, and in the second iteration, we'll mock it up. So based on historical data, we'll build a mock model. And in the third iteration, we use heuristics and past experience to predict the fraudulent transaction in the data set. And we would compare that in our fourth iteration, that our sample model, and compare it with the predictions which we have done during the in the previous step using heuristics. So if our sample model and that heuristics, so we would be able to set a standard. And in fifth iteration, we'll start refining the model, so CRISP-DM, using the CRISP-DM, and we'll keep adding more features, and we'll enlarge the dataset. So system design, there's three parts to that. In my opinion, we should be using hybrid, like because we have issues people would be concerned about data privacy, so we need to use be careful about that, and we would be using multiple data sources and large amount of data. So data centers can be used for that purpose, and as immediate results are not required, like we can have a like a huge amount of data and we can process it, then further process them in that manner that latency is low, and we can do offline learning. We don't need to do online learning in that matter, and also we can process in batch. Data transactions can be processed in the batch, and so it's that kind of system design which I would suggest for that. Risk and production are two. We can anticipate there would be data drift and the concept drift. Data drift in that manner, then increase in online shopping during COVID. So one example is that during COVID time, everyone was shopping online. And if we have set the limit, like in certain household, 10 transactions, if there's more than 10 transactions happening in a day, then it can be alerted as a fraud. But in COVID, all transactions were there, so it would be quite common that more than 10 transactions would be happening in a day. So data drift is there. Concept drift is that, like many times, the higher risk geographies, there are more online avenues to shop now. So even though from the high risk geographies, of course, there will be more online shopping happening. It doesn't matter. It doesn't mean that they all are fraudulent activities. So we need to be careful about the concept drift there. So, in summary, we evaluated the opportunity of and also with the crisp DM business understanding on that. We validated our solution through the plan, and we looked at our ML system design, and we discussed risk in production. So, thank you very much.